And now I'm going to hit broadcast and we are live.
All right.
We're rolling.
Welcome, everyone. We're here at the AIA Spokane 2020 annual meeting. We'll just have a short little announcements, some information for the membership, and then we'll turn it over to Katerra for their Catalyst presentation, which is the real reason why everyone is here. So a recap of this last year, didn't exactly go as how we planned on it going at the beginning of the year. Just quickly, our finances, our chapter is in good shape, if anybody's wondering about that. Our budget, we had a lot budgeted for travel, for a fall design speaker, which we did not have, and our design awards did cost less than they would have otherwise at the convention center and with the travel costs associated to that. So we will be having to take a look at the budget in our board retreat next week and looking ahead to next year and trying to figure out what we're doing budget-wise. And we'll be sending out the budget for next year to the membership in December, probably, and get a vote on that. So, and that will be coming from Ryan. Also, just to note, for those that don't know, in case you're wondering, also, about 10 years ago, the board established a reserve, an investment reserve for catastrophic economic fallouts and recessions as a way to help keep the chapter going if we had just really some bad time, and we didn't have to touch those funds at all. We don't plan on touching those funds at all next year. We think we're going to be fine, and that investment portfolio has had ups and downs, but it's still doing pretty well, actually. This past year, we started our remote live and local webinars. Those, as you know, we provide building tours. This is our main way for networking and for getting CEUs and for being able to share with each other our designs and the projects that have been going on in our community and with each other. And so we started remote live and local webinars as a way to do that through Zoom. We purchased the Zoom webinar subscription, and with groups like presentations like what Katerra is going to be doing for us here shortly, and Colin Swarman did last week, I think it was last week. Optic Studios presented Blockhouse. SPVV presented the park, their design there. We've been able to give CEU credits through that webinar series, as well as be able to show off our local work. So in this past, since March, we've been able to provide 8 webinars. Is that right? 8 webinars, 11 CEU hours, and 10 of those were HSWs. And all of those were well attended, with averaging around 50 people. And we would like to continue doing these for as long as we have COVID restrictions. The golf tournament went really well. It was much smaller than normal. We didn't have our normal swag at all the holes, but we did manage to make a little bit of money and get some, I think, just really needed in-person networking, but also do it in a safe way. We followed all the precautions, COVID guidelines, and I think the event went pretty well. And we managed to pull off the design awards. We had it all planned for April and then had to completely redo it. And we had 36 entries, 10 firms participating. And I just want to say thank you to everyone in the golf tournament, the golf committee and the design awards committee, everybody that just scrambled and helped pull it all together, did an excellent job. And I think we pulled off a pretty good design awards. And it'll be interesting to talk with your firms about how that went and in 2 years, what will our design awards look like? Did people like the online presentation, or are you really excited to get back to an in-person presentation, or do we do some kind of hybrid? So I think that'd be an interesting conversation for us to have with our members, and we're open to that feedback. So we did start a new web page. It ties in with the AIA Nationals web page. You can see the URL there on the screen. We're going to be adding content to that throughout the year, and our old web page is still up, but we'll be transferring over information, and within the next year we'll be losing the old web page. We started a YouTube TV channel, so all our webinars that we are producing will be found there, so you can go back at a later date if you want to see it, or if it was your company that presented it, you can share it. It'll be a good source of being able to find that content again. Did you have anything else you wanted to say about any of the recaps, Stephanie, to add to that?
Just that you can find the YouTube channel right off of our new website. So you don't have to be searching on YouTube. It'll take you right there.
Great. So we did send out the member survey, and thank you to everybody that responded. We're going to be using that at our board retreat next week, to help figure out what to do next year. It's still all kind of looking into the crystal ball. We're not quite sure how it's all going to turn out, but we're going to do our best, and we really appreciate the feedback. Two big things that came out of the survey: that people are very interested in the virtual building tours or the online design presentations. And we have started talking about being in contact with a nationally recognized design architect, that we can have an online panel design presentation with them. We're kind of excited about that it could be a way to have kind of an intimate and a little bit interesting way to dialogue with them. So we're going to be working on that. That's so if people want to be involved, we'd love for people to be involved in that. So contact the AIA if you're interested in that, or your board member. And another, on the design presentations, we really need firms to volunteer to put on some of these presentations similar to what Katerra is going to be doing here shortly. And it can be whatever format you're most comfortable with. What it really is, kind of sky's the limit. We need to follow the AIA CEU format, but if you don't want to do a virtual building tour, that's fine. You can do a design presentation, such as one that we developed for our clientele. So whatever's most comfortable for you, but we really do want to keep continuing to provide the remote live and local webinars, but we need your involvement to do that. And the other thing on the survey, 60% of the responders have been members for more than 10 years. So we really encourage all the firms to encourage your younger staff, your emerging professionals to get involved in the AIA. There's a lot of professional growth opportunities for some of your the younger people in your staff. So please consider that. So the next slide, going to present our slate of officers for next year. Do you want to do this, Ryan? No, okay. So Ryan Zane will be our president next year. President-elect is Georgia Harder. Secretary is Brad Hackala. Treasurer will be Aaron Tarrin. Stephen Hewitt will continue on as a board member. Michael Cole will also be continuing on. Brian Pipo will be continuing on. And then new to the board is Heidi Pierce from MMEC Architects and Luke Grimsrud from Uptick Studios. And I will be the past president. We will be sending out the votes as we have in the past. So please be looking for that. And please respond right away on those, because the sooner we just get the quorum, the fewer amount of times we have to keep emailing the vote out. So
I would
thanks.
expect that to come out early next week,
Okay, great.
your emails. Yep.
And I did also want to mention big thank you to our board members that are leaving. And that would be Becky Blankenship. She's been on the board for 6.5 years. Let's think about that. And then Boyd Lucaretta is also leaving. He's been on the board for 3 years. And just huge thank you to both of them. They've just given a huge contribution to the board and into AIA Spokane, and some of the things that they've done have really, all the members have really benefited from what they've done. So thank you. And now I'm going to hand it over to Stephanie.
Thanks, Kathy. And I thank the board as well. I always get a new set of people to work for every year, and it's always fun and exciting to see how that changes. So go ahead and roll the next slide. So I have the pleasure of introducing our webinar, our remote live and local webinar that's going to happen tonight. And it's the Catalyst Tour and Presentation, which, as you know, is one of the largest CLT buildings in the state, and a new home for EWU, or another building for EWU. This course will give you 1 HSW credit. What I need you all to do, if you're AIA members, is go ahead and email office@aiaspokane.org, and I'll go ahead and make sure and log your credit. If you're not a member but want a certificate, please let me know that as well, and I'll get those out to you as soon as I'm able to do that. Go ahead and go to the next slide. Next slide, Kathy. And actually, I'll go ahead and go to the next one too, because you guys all know why you're here, but I do want to go ahead and present. Yeah. Actually, the second one where the presenters are. Usually I'm in control of the slides. If you can go back to, there you go. Next one, back. Second slide. No. One more back, one more the other direction. Okay, there we go. Presenters. We have everyone from Katerra presenting today. We've got Drew Clement, who's a senior mass timber architect. We've got Cora Todd, who's the construction manager. Hans-Eric Blumgren, who's a director of testing and certification. And our moderator is Sarah Smith, in conjunction with Drew Clement. They are encouraging Q&A throughout the webinar, so please use the Q&A portion down we all know Zoom, but it's right there at the bottom of your screen. Go ahead and pose your questions, and our moderators will pick them up and pose them to our panelists at the proper time. So with that, if you can just maybe go ahead and go into the learning objectives. Since we are getting credit, I do like to go through what it is you will be learning tonight. We'll be understanding the building code challenges and the solutions when using mass timber in non-traditional applications, including exterior wood curtain walls. You're going to understand how mass timber contributes to the health of occupants and safety of builders. And you'll understand the construction requirements of mass timber building that can impact upstream design decisions. And finally, you'll understand the challenges and process of developing a long span mass timber floor solution. Okay, next slide. And finally, I want to thank our sponsor, Freeform Workplace Interiors, for sponsoring this webinar. They were the company that provided all of the interior furnishings for this project in the University District for Eastern Washington University. And I know they're very proud of their work, and we're very thankful that they were willing to sponsor tonight. So with that, I'm going to go ahead and turn it over to Drew to kick it off. And I'll be back with you at the end. Thanks, Drew.
Thanks, Stephanie. Appreciate that introduction. All right, just want to check before we get in here. Does the presentation look full screen? All right, thanks everyone. And appreciate everyone on the call today with AIA or our affiliates or anyone else on the call to be able to present Catalyst. I know we had scheduled a tour this past spring, and unfortunately, with COVID, we're unable to do that. So we will do our best here to kind of go through the project. We do have a video in the middle of the presentation. I'm crossing my fingers that it will work. Hopefully, we've gone over those audio hurdles. And thanks to Stephanie for introducing. I'll kind of hop over these slides. We talked about the learning objectives. Thank you, Stephanie, for that. So let's hop into the presentation. So we split the presentation into 3 categories about the Catalyst project, hitting on design, construction, and product. Again, keying back to those learning objectives, learning about the mass timber project, and I think setting the stage for design is important here on this project, but also getting that feedback from the construction team, and then some insight into a company in developing a product through innovative mass timber solutions. So I think the important thing here is the perspective that we as an integrated team can bring here. So for the design portion of the presentation, I'm going to briefly discuss the project goals and some metrics just to kind of give a frame of reference to the project. So early on, there were some key goals that drove the project's design and execution. These goals were highly embraced by the client and the design team. So first and foremost, utilizing mass timber to support offsite manufacturing and fabrication. And this really helped lead us to innovative uses of mass timber, which we'll discuss later in the presentation. One of those innovations is the long span mass timber floor solution that Hans Erik will be talking about. That innovation precludes the need for concrete in order to get a long span solution in mass timber, the first of our knowledge of that type in North America. The net zero energy and net zero carbon target goals also led to innovative uses of mass timber solutions, specifically with the exterior wall assembly. And then last but not least, one of the goals of this project is to be a catalyst to Spokane South University District. So a brief list of partners on our project. The owner of Vista and McKinstry and the development partners. This was a Michael Green Architecture and Katerra design partnership. Where there's a list of some local consultants, but others with mass timber expertise. And then Katerra as a general contractor, but also providing mass timber engineering and installation, component detailing, and supply of most of the CLT on the project. A little frame of reference from a building perspective. So this is permitted under 2015 IBC. Obviously, there are tall wood building codes that are coming forth that do have a little impact to how we approach some projects with their use types, type 4 HTC, 4C. HT remains the same. Occupancy on this project is a combination of business, some assembly in the lobby and storage. The use is primarily higher education classrooms and labs. It was first bought as a spec office building. Again, construction type here is type 4 HT. We have a 30 by 30 mass timber grid and a variety of uses of CLT and mass timber listed on the screen. 5-ply floors and is the diaphragm as well, glue lam girders, beams and columns, some exterior columns, and then 3-ply CLT for exterior walls and 7-ply CLT for shear cores and walls, including a partial basement. Underneath 5 stories of mass timber, we have just shy of 165,000 gross square feet. We started this project in design October of 2017, and construction was complete summer of this year. So many of you are probably familiar with the project's location. The Catalyst project is located in the South University District area, just south of the established U District area, and situated just east of the South Landing University District Gateway Bridge. The first level of the project is most molded, we would say, to the site. The upper floors are more regimented and reflective of the design for manufacturing approach. Here, the Gateway Bridge is just off page left. There's a grand plaza that connects the public bridge landing with the Catalyst project's main south-facing entry. The project itself is organized around the central 2-story lobby, creating the east and west wings. And here are a couple of views, one on the left coming from the bridge landing, approaching the building, which is a very important design aspect that drove a lot of the design decisions. And then one, the image on the right, just from due south, looking towards the central lobby space. The upper floors are more reflective of the rigor within the structural system and the program organization. So here the second floor is partially carved out to provide a two-story lobby. The building is organized on a 30 by 30 mass timber grid, like I had said previously. This breaks down into 10-foot by 30-foot nominal sections, which then inform the overall CLT floor components, as well as the wall modules. And I think this is perhaps a beautiful image of the lobby and really speaks to mass timber and CLT expression. But a lot of the innovation in the building is in the bulk of them, or the bulk of the mass timber, the shear walls, the floors, and the exterior walls. So I'll be talking about the two components here, the shear and shaft walls, as well as the exterior walls. We had 7-ply CLT shear and shaft walls, just shy of 10 inches thick. From a lateral perspective, they use buckling restraint braces at the bottom of the panels to dissipate that energy. There's a couple of different finishes that were used for exposed and concealed spaces. And in some of the images, you may see that there's some gypboard furring around some of the stair shafts. And those are actually used as a design move to flush out adjacent CFS framed walls. That gypboard actually doesn't attribute itself to the fire performance of the walls. A few code challenges here. CLT is allowed as a material in Type 4HT buildings, but is not necessarily listed prescriptively or addressed in the building code as a shear component. So we work closely with our engineering team, as well as our code consultant team, to provide some engineering judgments that address the specific CLT shear and core wall conditions. So the diagram on the upper left-hand corner shows the CLT floor to shear wall condition, where we need to consider the spread of fire and smoke through those particular joints. We also looked at the 2-hour CLT shaft wall and the 1-hour CLT shear wall requirement, looking at those for calculated fire resistance, as well as Chapter 16 of BMDS. So a lot of our design drivers were around a shear wall free perimeter. We really wanted to prioritize transparency and also thought about decoupling prefabricated systems. So while each of the component of the CLT lateral system, sort of they're known components, but they may have been used together before. So we were looking to use off-the-shelf components in innovative ways. And so again, this is an image, a rendering on the left and an image on the right of the bottom of the CLT walls, where the BRBs are connected to the CLT and then to the mat concrete foundation. The walls stand approximately 70 feet tall, and they're spliced in the middle about level 3. There's a horizontal joint where there's epoxy dowels that are used to connect them. Through the process, we needed to go through some testing of the walls. So there's known data on the CLT performance itself. We needed to test the actual corner conditions to frame the stairs. This testing was completed down at OSU in conjunction with our engineer KPFF. I think was some really great, interesting images as the CLT is going in with the shear walls being erected. Obviously, from a sequencing standpoint, there's a lot of impact downstream to the construction teams that we have heard from a sequencing standpoint would help inform design decisions upstream. The image on the left shows some of the pre-drilled holes to receive the epoxy dowels. One of the goals of the client as we got into the design development was prioritizing egress stairs as a means of access between floors. They really wanted to look to them as to provide a warm and atypical experience by exposing the CLT. So that's where looking at the CLT through a char analysis, showing that the CLT itself fire attack on one side. So after a fire attack of 2 hours, the CLT would char up to 3.8 inches and still leaving enough CLT to provide structural integrity. And another beautiful image of the finished product. So here I want to move on to CLT exterior curtain walls. Some days we call them curtain wood. It's a 3-ply CLT, and there's a list of components that make up the buildup of that particular assembly. A sheet applied WRB, a combination of insulated metal panel as well as mineral wool insulation, and then the rain screen cladding is terracotta. So a few co-challenges here for the exterior wall, and it's sort of cyclical with 4HT. So we're allowed to have, 4HT allows the use of CLT in an exterior wall. It does provide some prescriptive requirements for its use, thickness, dimensionality, as well as coverage of a non-combustible material. Additionally, when we look at the requirement under Chapter 14 for exterior walls, in Type 4 construction that are greater than 40 feet in height, and a PA 285 comes into place. There's the exception that applies that walls in which the WRB is the only combustible material, that CLT would be fine, but here we have the WRB and the CLT, which are combustible. So what we did to address that is work directly with the city of Spokane to walk them through the design process, address their concerns early, and then work with our code consultant to draft the AMMR, which is the alternate means and methods request, and the engineering judgments, excuse me, to address them. Essentially, the point with the exterior wall is to not require the testing such that the WRB does not increase the vertical and lateral fire spread of the assembly due to its low flame spread index. Because this is a curtain wall system, there's movement we need to accommodate, and so those joints in the vertical and horizontal orientation of the panels did come into play as we looked at how to address them. So this is a quick plan diagram showing the location of the prefabricated CLT curtain walls. They occur from levels 2 through 5. The system did require a considerable amount of time and effort beyond just engineering and design evaluation. There are multiple scale mock-ups to test a concept of that constructability issues, and ultimately to gather data on what we're calling an extrusion system where the panels came together. This is an example of that extrusion. What actually came out of that was it was not very cost effective, right? And so we worked with our construction teams and suppliers to identify more off-the-shelf system that VaporShield was able to quickly take a look at with a silicone strip and provide a solution that worked well. Part of our documentation included fabrication level drawings, which identified each layer of the wall assembly, like I talked about earlier, in a series of drawings for each what we're calling mega panel type. So these are effectively 10-foot wide, 30-foot nominal panels. The intent was to prefab the entire panel. The terracotta logistics proved a bit too steep, I think, all around. Enough that our teams could not achieve that. But given the schedule conflicts, we needed to look at an alternate solution, which was partial prefabrication. This included factory application of the WRB, pre-flash window openings, and the insulated metal panel and rail system. So a quick brief here on the challenges. As a one of a kind first of its kind, there were a lot of hurdles that we needed to go to climb over from the onset of the concept all the way through the final detailing and installation. The finite engineering of the panels did prove a bit difficult. As a 2-story panel and as a curtain wall, it needs to accommodate the movement occurring across those 2 floors, which increased the vertical and horizontal joint sizes. Reconciling the design vision with constructability, I think, is another challenge. And working with Cora and her team, we were able to obviously install a really beautiful system. And here's a few images looking at the window installation. And I think with some feedback that we would say from this perspective is we looked at a couple different window solutions, flange mounted versus block set. Ultimately, I think block set was decided to go with because of schedule issues. But I think the important thing here is the takeaway is the mock-up. Working with the mock-up with the construction team is obviously very important. And a few additional install images here, working from the left to right. After the prefabricated panels installed, terracotta was placed with the flashing final trim and then metal panel. I think some key outcomes of the exterior walls specifically, from a design perspective, is increasing daylight penetration into the building core, which helps reduce the lighting loads and power density. Mechanical system benefits through a highly insulated wall assembly. Obviously, is reduced energy needs and costs, as well as upfront equipment capacity, size, and then reduction in acoustic levels. The CLT opaque wall portion averaged just shy of an R36. And there were some really wonderful QC protocols that were put in place for this building that allowed us to get an air leakage rate that was well below code and was the lowest air leakage rate that our consultant had ever tested. Obviously, with the use of 3-ply in the exterior wall, a lot of CLT was used, a lot of carbon was sequestered, but also the improved occupant working in an learning environment, I think, is obviously very important here. So I'm going to take a quick pause here and move to a video, and hopefully we get the audio to work.
Hi, I'm Cora Todd, Project Manager for Katerra Construction, and this is the South Landing Catalyst Building. And I'm excited to take you for a tour. Let's go take a look. In the Catalyst Building at South Landing, it's 160,000 square feet of Type 4 heavy timber construction. We use glulam beams out of Canada, and we use 3 different sizes of CLT in this structure. The 7-ply shear walls are by Structurlam. The 3-ply exterior walls are also by Structurlam, and the 5-ply floor panels, both in flat panel and built up double T panels, are from right here in the Spokane Valley out of our Katerra CLT factory. It aims to be one of the largest zero energy and zero carbon buildings in North America and will pursue zero energy certification by the International Living Future Institute. The 5-story office building is a result of a cross-industry team of partners, including utility provider Avista, design build engineering firm McKinstry, and Katerra. Working with Katerra design partner Michael Green Architecture as the design architect, Katerra is the architect of record and general contractor for the building. The building makes extensive use of CLT in design and structural elements, including floors, shear walls, and building envelope, which enables near passive house levels of thermal performance. So let's start by looking at the 7-ply panels from Structurlam. 7-ply shear wall elements erected in 2 lifts using a spliced epoxy rod system allowed for ease of erection and constructability. We were able to gain quite a bit of schedule using this system, even having to do a half-lap joint in the middle to span the lengths that we needed. And you can see here, this is where these 2 panels splice together and the screws tie them to each other. Katerra needed to use 7- and 3-ply panels from Structurlam because at the start of construction and when we needed to start producing materials, Katerra was only certified to produce 5-ply panels. We have since then received our certification to produce 3-ply panels and are currently in process for getting certification for both 7- and 9-ply panels. 10 by 30 3-ply exterior wall panels from Structurlam are built up of 3-ply CLT, rigid insulation sandwiched in metal panel, plus a rain screen system that has terracotta panels on the very outside. This was important, according to our acoustics engineer, in order to minimize the sound transmission of the active railway to the north of this site. The 3-ply panels came to us with window cutouts already present. We then installed punched window openings, which are triple pane units from Euroline windows in Canada, and the exterior envelope has an R40 average because of the minimal thermal bridging as a result of the CLT. The use of CLT in exterior walls of Type 4 heavy timber buildings is allowed. Katerra worked diligently with our code consultant and the City of Spokane to ensure all fire life safety measures were addressed with regard to flame spread. The floor line fire stop assembly is typical as found in aluminum curtain wall to concrete deck building. What we can still see, because TI renovations have not begun on this floor, is the gravity connection steel plate connecting the CLT 3-ply to the perimeter glulam beam beneath this gypcrete. The primary tenant for the building is Eastern Washington University. They occupy approximately 60% of the building. EWU is relocating some of their technical programs to this building, including computer science and electrical engineering, ideal programs to be located in this type of structure. The grid was set up on a 30 by 30 spacing, which while not completely efficient for CLT, we were able to manage well by using ribbed panels, essentially a double T made from wood fiber instead of concrete. To our knowledge, this is the first application of this technology in the US. The Catalyst building utilizes the very first product off our factory floor. Not a single panel was sent back. We are 100% on quality for our first project. Every piece of wood that you see in here is an SPF, or a spruce pine fir mixture. We upsized the glulam beam in the center bays to allow for flat panels instead of the built-up double Ts. Upsizing the center beam allowed for running of mechanical systems through these center bays and then out into the outer bays via the castellated beams that you see here. Low air leakage equates to very high performance. It's the metric that tells you how the building will perform and whether it reaches the very minimal energy allowance of a passive house building. Passive house needs to have uncontrolled leakage through gaps less than 0.6 of the total house volume per hour during a pressure test at 50 Pascal, both pressurized and depressurized. The Catalyst building measured an air leakage rate of 0.035 CFM per square foot, which is significantly below the code requirement. The results demonstrate the great workmanship and management by the Katerra construction team and rigorous detailing by the design team. Air tightness is difficult to achieve in a building of this size. Air tightness tests were done by RDH, one of the leading envelope design firms in North America. They have done over 100 similar tests, and the Catalyst building performed better than any building they have ever tested. Integrated wood slat system from Okalux was important also to achieve the passive house rating. You can see demonstrated that while I have sun coming through my punched window openings, we don't have sun coming through this very large curtain wall space. On top of our CLT panels, the floors have a 3/4 inch Acoustomat and 2 1/4 of gypcrete on top of that. This was done in order to minimize vibration from pedestrians and people walking through the structure. Panel to panel spacing, behind this piece of trim, we still have about a 2.5 inch gap, which allows for interstory movement of up to 3/4 of an inch per panel. So if in case of an earthquake, these panels would shift independently and not conflict with each other. One of the structural elements in this building is called a BRB, a buckling restrained brace. There are 22 of these at our shear course. These are concrete-filled steel tubes that have steel plates running through and basically act as a stabilizing tool that if this building were to start rocking in an earthquake, they take the forces from the diaphragm above and drive them into the very large concrete pads that we have underneath this stair core. And that happens at all 3 of our stair cores and at the knife walls in between throughout the structure. We added an extra beam at the center bay to eliminate rib panels within the center zones to allow for main distribution around the core above the corridor, then feeding branch ductwork through cutouts in the main glulam girders. The CLT within the core is an efficient span of 15 feet. The omitted beams allows utilities like ductwork to be installed tighter to the underside of the CLT. An environmentally conscious choice in this structure included capturing waste that could have gone through the chipper and utilizing it for other parts and pieces in our building. This included getting the window cutouts that came from our 3-ply panels and utilizing them for my stair treads and risers and landings in these stair cores. The finished surface in this area is going to be a rubber tread and riser, but then the underside of the CLT is all going to stay exposed. This is an example of part of the tenant build-out that Eastern Washington University has done in the Catalyst building. This is a VDC classroom, and it showcases the cloud system by Overcast Innovations and installed by McKinstry. The goal was to maintain open space while distributing electrical, mechanical, and fire alarm systems throughout the space. Commercial buildings are not required by code to provide for perimeter power. Katerra Design worked closely with McKinstry to develop strategies for routing conduit across the ceiling, through perimeter beams, and down the exterior wall in discrete locations when necessitated by future tenant fit-outs. Most office systems and layouts are serviced by floor boxes or through adjacent framed walls, which omits the need for such perimeter power and data. In this main lobby between East Tower and West Tower, Katerra and Michael Green Architecture really wanted to emphasize vertical wood elements as well as CLT panels that extend past the perimeter of the building via our cantilevered awnings. While the majority of this building is made out of wood, in this two-story lobby, we did have to use steel elements. That steel, because it's exposed, needed to also have an intumescent coating applied before we put the finished paint on it. Now, the floor panels of level 3 create this lobby space, and Katerra thin 3-ply panels are then used as a veneer to span between rib beams. When we put 3-ply panels from beam to beam, we created a concealed space. And because of that, Katerra had to use a fire-resistant coating because that area is not sprinkled. Katerra commissioned the Carbon Leadership Forum and Center for International Trade and Forest Products at the University of Washington to analyze the environmental impacts of RCLT as well as the Catalyst building in Spokane. These two organizations are the preeminent leaders in their respective fields. CLF recently released an embodied carbon calculator for the construction industry, and Centrifor is well known for its research to support sustainable forestry and forest products trade. Our goal in pursuing this analysis was twofold: to better identify opportunities to reduce environmental impacts in our supply chain and improve CLT production efficiencies, and to eliminate the life cycle environmental impacts of mass timber at the whole building scale, identifying opportunities to optimize the environmental performance of mid-rise mass timber structures. The Carbon Leadership Forum found that mass timber nearly offsets all upfront embodied carbon in the Catalyst building. The life cycle assessment of the Catalyst building structure and envelope estimated the upfront embodied carbon of the building to be only 207 kilograms of carbon emission per square meter. Considering the Catalyst building stores approximately 204 kilograms of carbon per square meter of biogenic carbon, the CLT and glue lamp elements offset its upfront embodied carbon. While the study did not make direct comparison of the Catalyst building to similarly sized buildings constructed out of steel or concrete, its upfront embodied carbon impact is significantly lower than that of other North American commercial office buildings in the embodied carbon benchmark study. So I think that was important when applying quite so much hard surface in this main very tall lobby area, was that we had to use quite a lot of sound insulation board behind all of the horizontal and vertical panels to make sure that while this was an open space, it's not a loud space. So now we're out on the north patio in order to show you first how our Katerra CLT panels look in the cantilevered awning, but also to show the Alaskan yellow cedar siding showcased on the north and east elevations. So here we are on the level 2, soon to be occupied deck for the Catalyst building in order to show you the terracotta rain screen system by Schilden that we ordered out of Germany. This system uses a vertical clip and rail system in order to take these approximately 3 feet by 1 foot panels and hold them in place.
Wonderful, thank you, Cora. And with that, actually, I'm going to hand it over to Cora to kind of get some additional construction feedback.
Thanks, Drew. So I'm hoping I'm not going to be repetitive in some of these things that I'm going to talk about. The Catalyst building was not just a first for, is there an echo? There we go. Okay, there we go. Wasn't just a first for Katerra, it was a first for me. It was a first timber structure for me. And then, so there was a lot of benefits, a lot of learning, a lot of, okay, how are we going to get this done from a construction perspective? What was really important as from any construction standpoint is how are we going to keep the men and women working on these sites as safe as possible while we put up this structure? And I'm sure you all know, the largest risks come when the building is not fully screwed together in this instance. And so what you see in this picture is some of the temporary bracing that we had to erect. What we did find is that some of the safety benefits that we were able to design and then construct into this building were that the more we unitized, the more we panelized, the more we were able to build in complete items into the structure, the shorter duration we needed to have in order to erect this building. Those rib panels were an excellent way that we were able to do that. And so, and as we did that, that also reduced our time on site for the most part, and got us to the next trades quicker. The Catalyst building was a learning opportunity for all of us, and we gathered a lot of information, a lot of data, a lot of the, I had an intern out there a couple of summers ago who just timed crane picks, and we got, our longest crane pick was probably a half an hour when we were first starting out, and then we got down, the fastest pick was in 7 minutes, which was really important because then we take that information, we feed it back into our teams, specifically on the construction side, but also on the design side and pre-con side, to say, okay, we can average about this. And so using those metrics is really important. The factory being so close was actually really important also. It was a unique situation to be just, half hour, 20 minutes away. But that did allow for us to, again, it's almost like the truck itself was a unitized system, because it was just in time delivery, pick and place from the truck bed itself. So some unique perspective there that came directly from the design side. So I can appreciate that. Next slide, Drew. Let's see. So more safety benefits. The less time I have to spend on site, the safer everybody is, because there's less exposure to risk. The rib panels and flat panels, just the structure of the building itself allow for that. Because if we compare it to steel, right? If we compare it direct relation to steel, so in steel, okay, let's put the concrete down, that's the same, right? Put the steel up, that's similar to glue-lam columns and beams, right? But then on steel, then I have to come back and weld down metal deck, then I have to come back and put down rebar, then I have to come back and put down the concrete topping on top. And then the structure is, safe for the most part in regards to an erection engineering perspective. With CLT, what's important there is we eliminate a couple of the let's come back and make sure that this is secure. Obviously, we still have our temporary erection protection, but we've eliminated the need to come back and weld on a deck because we already have our floor panels in place and the structure is secure that way. And as far as during construction activities. Another important but kind of not often talked about safety factor for the people on site is that CLT buildings, as they're going up, tend to be less noisy, and noise pollution is some of the tough guys don't want to wear ear protection, and if they choose not to, well, my building sites, if they continue to be mass timber, they protect them inherently because we have less equipment on site. We have, in regards to concrete trucks, on-site welding, things like that. And then also, because the wood has it was, Drew, you can remember being out on site, and it was quieter. It was a more enjoyable environment to be in. I've been in concrete and steel structures, but it really was lovely to be in a building that was still being constructed, and that was really interesting. But next slide. Thank you. So the feedback loop that I've been thinking about for the past couple of weeks, if I were to relay information from a construction perspective to design team personnel, from the ground up, if we did it again, what would we learn? What helps is so timber is unique, but it's also not unique. Like we've got a really good, robust group of manufacturers that can supply product. Katerra happens to be one of those. But what helps us is identifying, okay, this is what the structure needs to be. This is what our design values are. And I mean, it's as simple as listing 3 options that are local. You know, if it was a paint spec, you would list Sherwin-Williams and Rada and whoever, right? But so with Glulam and CLT, okay, here's our providers, and these are the ones that it's not just Structurlam, it's not just Katerra. You know, the Katerra and Structurlam and Nordic or whoever it is, give construction the opportunity to be able to maximize relationships, and also the flexibility to say, okay, Structurlam's panels are a little bit different than Katerra's, and Katerra's are, you know, a little bit different this way. So is Katerra's product going to work better? You know, being willing to have the conversation was really important. Finishes. We had a lot of different finishes in Catalyst, and while it is a very similar finished product, we had a finish matrix that could rival pretty complicated structures, and that was because we were trying to so I mentioned in the video, most of the structure is SPF. There are elements that are Alaskan yellow cedar, but the intent that MGA was really stern on was that we wanted to maintain cool tones in the wood and cool tones in the finishes. And so it's like, okay, wood is inherently a little bit warm. Thankfully, they selected an SPF product, which kind of tones down, at least neutralizes some of those warm elements in the Doug fir that we see, like in Doug fir. But then we have Alaskan yellow cedar, and like in its name, it tends to be a little bit, it pulls yellow, for heaven's sake. So we had a lot of trial and error that brought us to, okay, we need to put 3 coats of this on this surface and 3 coats of this on this surface, and they're in the same area of the building, but it's important because of X, Y, and Z. And so understanding the intent to begin with, hey, our goal is we want to warm up this product. Our goal is we want to tone down this product, and then allowing construction to help, again, maximize our relationship with product suppliers. And I mean, there's plenty to go around in the wood finishing world, but allowing us to help and come up with options and come up with, hey, if Sanson's the spec, then but you're willing to entertain Cloverdale, let's talk about it, right? And mostly I think that's the theme of my part of this program is let's talk about it. Let's communicate, let's work together, let's come up with ideas that work best for everybody, right? And then starting from the beginning and starting from design, and then starting with, oh my gosh, get your mechanical design done so that I know where all the holes need to get poked in this building, because the more I can do in the factory, the more, again, back to that unitization, repeatability, and also producing in a controlled environment like the factory, like our factory specifically, I can get you penetrations where you need them. You just have to tell me where they go. And if you don't tell me where they go, then we're probably not going to get them. And so then it's a matter of, okay, now we have to drill them in field, and that's just added complication. That's not necessary as long as we're talking early enough. Next slide. Turned out really beautiful, like the terracotta, the Okalux, terracotta by Sheldon, the Okalux, some of the options that we exercised on this building, the design options, really lovely, but also incredibly difficult to get. Well, not necessarily difficult in that they don't exist, but definitely difficult in the sense of they're an ocean away and they're 24 weeks lead time. So we had better be certain of colors, certain of profiles, certain of, I mean, you see in the picture here, there's probably 7 different profiles of terracotta tile on there. And so that all of that uniqueness is really important to the finished product, but it's also really important to know, okay, we're sure. And so thankfully our design team did a really good job of digging into and being like, yes, I'm going to. And of course you would review the shop drawings diligently anyway, but these took a lot more. It's like, yeah, okay, this is profile P17 on the east tower of 47A or whatever it is. I think that Drew's eyes crossed with looking at shop drawings for terracotta tile after several weeks, but it was really important. And then we had there, I mean, it's nothing to do with it. It wasn't the design team's fault, but we struggled getting the Okalux glass here in time. But so then I'm supposed to speed up a little bit. That's fine. Innovation. I think that I probably just captured that. It was difficult, but it was really important. And I was really thankful that we were able to do it. Next. Moisture mitigation, mostly we just, during construction, we pay attention to it. It's gonna happen. It's gonna stay in the wood. We need to make sure that construction has a plan in place to protect the wood as much as we can, and then mitigate from there. And sometimes that means washing, sometimes that means sanding, sometimes that means, well, we did our best. But the factory builds in tolerances, and thankfully the wood stabilizes from there. Next. I kind of already talked about erection engineering, but these pictures specifically are to show what dirty steel does to finished product. And that's something to keep in mind when we are designing these types of buildings. And me, when I'm erecting them, it's a finished product that we're putting up. And so it's like putting up painted walls. So let's be mindful. I mean, I cringe every time I see this picture because I see all that dirty scaffolding resting up against my walls. And it's like, well, shit, now what am I gonna do? I'm gonna have to sand, I'm gonna have to wash, I'm gonna have to see, do get that fresh, because that is gonna be an exposed product. Material tolerances. Concrete is different than steel. Concrete is different than CLT, different than steel. We design to a 2 millimeter tolerance, I want to say. And that's not what we build concrete and steel to. So we had some issues with that, and there was limited flexibility. We had to cut out and try again. But the mindfulness of, we've got tight tolerances on above the concrete and less tolerances below the CLT, just something again to be mindful of. Next. Ooh, these were little details that our ownership didn't actually end up liking. While it was really important to keep the wood up off the concrete and up off the floors, because that edge can soak up moisture and cause staining, it also can collect dust, and they didn't like that. So we ended up discussing the program ahead of time with your ownership. Hey, what do we think about these drilling into the details, right? Where someone might like it, our owner we ended up putting trim around it. Next. Fire stopping. Hans-Erik should talk about fire stopping, but thankfully we have, it's as long as we get around the idea that it's not different than anything, it's different than anything we've done, but ultimately the building is made out of wood, and it will burn itself out before it will burn itself down. And from there, Hilti helps us with the rest. Next. And these pictures are specifically about concealed unsprinkled spaces. The picture up at the top is an fire resistant coating. It doesn't necessarily act as an intumescent similar to steel, but it was necessary because, like I said, those spaces are unsprinkled. And where you saw in the lobby area, those beautiful panels up above and underneath those is where all of this coating goes. And then those are the steel connections that eventually, walking through the space, you don't see any of that steel. It was important to cover those with wood caps that came from the glulam manufacturer. And that was a detail that we had to work out when they finally got there. Next. And so Hans Erik is going to talk to us a little bit about products and options and manufacturing types and
Thank you, Cora.
the science.
Can you hear me?
Yes.
Excellent. I'm happy to jump in here, move it up a clip. But this is some, we've been looking at the building and talking about CLT, but kind of what is it at the product level is my goal here. And I'll run through these slides. A key one is every manufacturer usually makes their panels in a large format size. Ours is very large. It's 10 to 12 feet wide by up to 60 feet long, every press. It's laid up, you know, with the crosswise layup is shown there in 3 to 9 ply. The utilization of that panel in your module and your, you know, some discipline and design to make sure you can use every part of the panel when possible is a key design driver early on. And that can be done through automated processes with the CNC cutting, right? So we get like, well, you know, it's like steel shop drawings kind of with wood shop drawings. Every piece of wood has a mark and gonna get CNC cut. Next slide. And you know, even routing out for some end connections, some routing out for mechanical, electrical, plumbing, and sleeving. These are all options. And what you get is a dimensionally stable and high tolerance product in the field that our builders, Cora and her team, have kind of heard it was true, and now they've seen it's true, just how these buildings self-erect. They chainsaws aren't allowed on site, right, Cora? So they don't have to go out there and trim it later. It self-levels, self-erects itself in that manner. So that's a layup table. So when you or the engineer need to go look at our layups and thicknesses, and there's design values here, we have our third-party reports that get into each layup and have a diversity of layups there. As you can see, from SPF to Doug Fir, and 2 stress grades are shown here. I'll keep going so I don't get lost in that detail, but here the product literature is there too, right? So the CLT website gets into the specifics on our certification and how to work with our material and third-party report. On the rib panel assembly then, that is a huge experience on my end to help see this through. We got a performance specification from the structural engineer record. So Katerra engineered that rib panel as a product and worked. And then my theme here, as you see the amount of effort we put into this product, it's all testing, testing, testing. So data is gold. Engineers and architects want to see the performance metrics, because to span 30 feet with CLT gave us pause, and 30 feet is a key module here for the education, if not office, to have that 30-foot span. So we analyzed it and now proved it out through testing. So next slide. There's a rendering of the building, kind of the integration. As you can see, there's a gypcrete topping with an underlayment as described on the left. It's lightweight because we mechanically fasten the ribs to the underside of the CLT, 2 of them per 10-foot panel. We get composite action, so we get a very efficient cross-section, shallower beam depths, but still get the strength and stiffness we need for structural. Next slide. I won't delve into this one much more. I did a structural engineering talk earlier today and had this slide in there. But we tested to, again, there is a standard for pre-construction load tests in the code. So we took a very literal view of the code, and the best way to get building official approval is if you have some test data that shows it works. So we did that on just the structural strength side of things, which was key. Next slide. Then we built a process in our factory and had to meet everybody at the manufacturing facility, to the construction crew that was here making 300, 400, how many panels? I think many panels in about an 8-week period. They made all of them, which was cool. But we had to develop this process of ribs, glue, applying the glue. Let's see what the next slide is. I might have put the image of, here's the glue process. And then we screw and glue it together. So we get a big clamping force with these big screws that you can see in the top left, squishing the glue and getting that bond line durability. I like to actually point out this is one picture of us putting it on craft paper to We had to get the glue volume right and troubleshoot some of that, but it also was a quality assurance program. So we could roll up every morning, we'd measure our glue weight by rolling up the craft paper on a scale and making sure we were on spec. Next slide. And there's great profile that you actually can't see in the building anymore because I guess, it really emphasizes the slenderness of the span, and that's the efficiency we're talking about. Next slide. So then we packed up 3 of these prototypes we built and shipped them down to Oregon State University. Next slide. This is where we stepped through our mechanical testing, where we confirmed the strength and the stiffness of these panels. So an engineer could assign a design value to them. And again, vibration was super key. So we could confirm to ourselves in the engineer record that, hey, this is a stiff enough panel for our calculation. So that was a key thing and super formative. We did this testing about 4 weeks before the first panels went up. So we were in an amazing place to deliver for Catalyst as a first project. There's a picture of that deflection and the emphasis on the stiffness there. When you don't get composite action, each panel, CLT and rib, deflects independently, but once you can glue and screw them together, you get this composite cross section, like a double T in concrete, sort of. Next slide. Oh, there it is, about a factor of 4 difference. All right. And then, we break it, we look how strong it is, and look at failure modes. This is all part of good engineering and all done with the intent of doing this again on a project, not just making it work for Catalyst, but really looking at this as something we can build out as a product offering. Next slide. And we've seen enough of these. Next slide. And the install, that whole story is there. Next slide. Then vibration testing. So the engineers modeled these floors with techniques and guidance that's out there in the market. So that set kind of where we had to be on the stiffness of the panel. And I won't go into the math there. Next slide gets into the field testing though. So we've gone back and actually measured this performance of how much does the floor vibrate when people walk on it. Is it perceptible? Is it going to be onerous? And the results have been very positive. Next slide. This is why you got to get a tour. And I was out there with Drew 3 weeks ago to finally take the final measurements, and I was having a good time because it's such a solid floor, and we spent so much time concerned about how it performed. So there's a paper here where we've captured frequency, damping, these response factors. It kind of gets technical, but this is kind of our 10-page write-up on the whole development of the product that I'm excited that we have issued now, and happy to send it to somebody if you want to follow up later with understanding how you can design with it and how it performs. And there's a little more to the story. What's next? Yeah, acoustically too. So there is a growing amount of data. When I started at Katerra 4 years ago, there was one Intertech test report for a framework project in Portland that never got built. And we used that for a very first project, not even this one. But since then, Woodworks is bringing a ton of guidance. Maxon and USG have both come to the table with performance testing of their finishes on CLT. So we can now actually boil into real performance criteria and with confidence during design. And Maxon cares about performance too. So with our help, they went back and field tested because they know this data is gold to understand how it worked. And so we just got that report from them when we're reading through it, but we met or exceeded the performance requirements specified by the consultant in the design. Next slide is a handoff back to Sarah, I think.
All right, thanks. Drew, do you want to wrap us up, or should I plow in?
Yeah, go ahead, Sarah. I think there's a few slides here, then we'll wrap up with our Q&A.
Okay, great. So we wanted to close with a few insights into how Katerra engages both on this project and generally from a services and a product perspective. And then we'll welcome questions from everyone on the project and on the company. So Katerra is a fully integrated end-to-end provider And I'll focus these comments on mass timber. There are other parts of the building value chain that we operate in, but in the world of mass timber, we have in-house design with MGA, as well as architects within our mass timber business unit that provide design assist support onto projects that have an AOR already in place. So we really flex our team's involvement on projects to meet the capabilities and experiences of that project team. So that's in the form of design, architecture, as well as engineering. Our in-house engineering firm is Equilibrium Consulting, but we also have structural engineers within the timber business unit that also provide that flexible design assist support. On the material sourcing side, Cora referred to this, we obviously fabricate our own CLT, but we source the structural systems that would support that. So that's a glulium, as well as increasingly we're seeing more and more projects with steel systems, so CFS or structural steel. And our team is well equipped to source those components, as well as any hardware or connections associated with the timber package. Manufacturing, which we've talked about a lot, and then construction, as on the Catalyst project, we have general contracting capabilities where we can be the end-to-end builder as a GC or in design build capacity. But we also can just carve out the mass timber erection scope on projects where that makes sense, where our client is the general contractor, not Katerra, but a third-party general contractor, and we can provide the full scope of timber erection, or also kind of scale that back again, like as in the case of design and engineering, to just provide an on-site assist to skill up the self-perform teams within a GC partner. Here's a quick snapshot of projects that we are looking at today. So there's a nice spot up there in Spokane. But we're looking at projects around the country where we're delivering engineering, design, and really scalable projects. So in some cases, maybe materials only, maybe design assist and install on top of the timber package. Here's a bit more detail on what I covered on the first page, which is our in-house kind of suite or menu. I would think of it as menu of services that we pick and choose from. One, I guess, additional detail on here is just logistics. So because we are fully end-to-end integrated, our logistics team is very closely connected with both the install team as well as the factory. So we key off of the construction schedule to organize the logistics, which includes truck loading, pick sequencing, and pick engineering to minimize construction time on site, so that in an ideal world, it's a just-in-time delivery with a single pick from the truck into place. And so that would minimize any potential damage to the panels from offloading and reloading, and also obviously accelerate schedules and decrease labor required. Another quick snapshot, some of the firms I mentioned, MGA, who obviously played a big part on this project. Lord Sargent is a national architecture firm that's in-house at Katerra that we lean on, particularly on academic and multifamily projects, and then Equilibrium. And then Hans-Eric referred to some of our academic partnerships with WSU, Clemson, and a handful of others that we work with from testing, from a testing perspective. Also not mentioned on here is partnerships that we have with supplier partners, so Simpson and Hilti, where we do product innovation and testing along with them. Here's a picture of our factory. I hope a bunch of you who are in Spokane have gotten to visit. It's really a phenomenal facility. We have the largest production capacity in North America, and it's really in line with Katerra's mission around bringing technology to construction. We've invested really heavily in the technology underpinnings of this factory. So, for example, at the upfront materials intake line, we have an AI system in which every board that comes in is read and scanned for its structural properties, placed accordingly in the panel layup and pressed, and that allows us to minimize waste. So we're placing the panels according to where the strength is needed. So that benefits both from a sustainability impact as well as a cost side, because we're just paying less for the lumber inputs. We know that the sustainability values that Cora addressed on the building tour are really only possible and achievable if we are sustainably sourcing our materials. And so we or have 3 chain of custody certifications, FSC, PEFC, and SFI, which indicate, the rigor that we apply when identifying upstream suppliers that we're purchasing our lumber from. And then we have a declare label also and are underway on our EPDs. Hans-Eric touched on this. Here's just a kind of a menu of the products that we're currently producing. So the variations were actually represented very well on the Catalyst building, but we have 3, 5, 7, and 9 ply in SPF. We've recently over the summer gotten certified on a Doug fir, and we also have been certified in a visual grade as well as an E grade or increased strength product, which just provides higher structural performance ratings. And as Hans-Eric mentioned, the panel presses up to 60 by 12 foot panels. So those are important metrics to keep in mind. That really the name of the game when designing in CLT is minimizing waste. So you want to optimize full usage of that panel. There is some flexibility in the size of the panels that we press. And there we are at the end. Thank you all. Drew, do you want to kind of wrap us up? And then I hope you'll send in some questions. We're happy to have this be an open discussion.
Yeah, thanks, Sarah. And I really appreciate the AIA keeping up with the CEs here. And I think, I know I've certainly appreciated the virtual tours and the online CEs, not just to get the CE credits, but to kind of continue to stay integrated with the local community. And special thanks to Sarah and Cora and Hans-Eric to join me in this presentation. And I think it's certainly, hopefully we can have expressed the importance of an integrated team when we're working on these types of projects. And I really hope you enjoy. So yes, please send in Q&A, or if anyone on I don't know if it's Kathy or Stephanie, if people can actually unmute and ask as well.
Cora, a question that we often get asked is around the floor topping and how you address the exposed CLT either from above and below. Can you address that?
So, you mean like the gypcrete?
Mm-hmm.
Okay, so on Catalyst, it was we had 3/4 of an inch of a Cusamat and then 2 and 2 1/4 of gypcrete topping, and that actually bumped up all the way. We had electrical penetrations that were in the electrical closets that had sleeves that come up, but similar to how when concrete gets placed, those had their sleeves in it, and you just pour right up to it.
Thanks. All right.
And then Hans-Eric came and walked all over the floor and see if it vibrated. And he jumped.
The jump test.
Every structural engineer that I brought through that building jumped on the floors.
Good. All right, well, we don't need to keep people if there are no questions. I'm sure people want to go refresh their news feeds to see what's going on in the world. We really appreciate you taking the time tonight. And I don't know if it's possible, maybe through Kathy, we can follow up with our contact information. We would love to answer any questions that anyone comes up with and help on any projects that you're looking at.
Great. Well, thank you, Katerra. We really appreciate your time and your expertise, and it's certainly an exciting building to have in our community, and your willingness to share your expertise with all of the community is great. So just can't thank you enough. And as Drew mentioned, I know there's 42 people that have joined this webinar, and I know you have your own expertise in things and knowledge bases. And so please, please, please let us know if there's something you want to share, if there's a project out there, if there's a particular expertise you want to share, we'll get you on the calendar for next year. Also say again, if you need credit, please email me at office@aiaspokane.org. We have recorded this and it will be available on our YouTube channel, which is also available through our new website. I should have it up probably by tomorrow sometime. So you're welcome to go back and view it and use it within your firms and continue to educate yourself, because that's what we're here to do. So thanks again to everybody that attended tonight, and also we're excited with the new slate of officers. We'll get those out early next week, and just get your vote in. We appreciate it. All right, thank you and good night.